We know that air is an insulator, right? Yet over here we see an electric spark in the air. Or if we talk about a bigger scale, we see lightning moving across the sky and many times also striking the surface of the earth. Still we see electricity moving through air. What is happening here? How is this possible? In this video we will explore how are these electric sparks created. Let's say we have a conducting metallic sphere and we give some negative charge to it. So this negative charge will get accumulated at the surface of the sphere, and let's say we keep on adding more and more negative charge to the sphere, so all the charge gets accumulated at the surface. Now we can't keep on adding charge to this sphere forever because something interesting happens. Not on the surface though, not on the surface of the sphere, but in the air around it. Air has many atoms. It has nitrogen, oxygen, some helium. So the atom that is closer to the surface of this sphere, all of the negative charge will repel the electrons of the neutral atom. And as a result, the shape could get slightly warped like this. You have all of these electron clouds slightly moving away. Now it is entirely possible that there is enough charge on this sphere so that it creates a strong enough electric field which can even strip this atom of one of its electrons. So as a result, you get an electron and an ion. Now this electron starts accelerating to the right because there is an electric field which forces the electron to do so. This electron collides with another neutral atom. And if it is going fast enough, it can knock an electron off the neutral atom, turning it into another ion. Now you have the original electron and you have one more electron that was knocked off from this atom. Two electrons are now accelerating and they collide with more atoms and they knock off more electrons, and then those collide further and knock off even more electrons, like a chain reaction. This creates an avalanche of electrons and ions. It's just as if we have a board at an incline with all of these balls held up by very thin rubber bands. So thin that you place one extra ball and the band will break. Now if you let one ball roll down from the top, you can imagine what would happen. This string will break and then these balls would start rolling down and break this string, the bottom string, and now all of those balls are rolling down. Just how the electrons are behaving in this case. But one more thing, if you reduce the slope of this incline, if you make it flatter, if you reduce the slope, maybe this ball does not have enough velocity or enough kinetic energy so that when it strikes the balls that are held over here, maybe it doesn't break the rubber band. So there should be some slope to this board so that the ball has enough kinetic energy, enough velocity. Just like over here, the electric field should be strong enough so that it rips off an electron from an atom and gives it enough acceleration or kinetic energy to knock off other electrons from other atoms. Okay, so spark, where's the spark? If now I bring a sphere of zero potential, and let's say this is grounded, it is at a zero potential, there will be some positive charge that is induced on this sphere. As a result of the negative charge that is all accumulated over here, there is some positive charge induced and there will be strong electric field lines from the positive end to the negative end. Finally, you get a region of space which is basically full of ions and electrons, and it is so loaded of these charged particles that it essentially becomes a conductor. A huge current goes between the two. This results in a spark. So that is how an electric spark is created. High charge warps the nearby atoms, stripping it away of one of its electron. You just need one, which then starts accelerating and colliding with other atoms, knocking off their electrons. And the same happens again. Eventually the space gets loaded with so many ions and electrons that the air essentially becomes a conductor and electricity starts flowing and a spark is created. Now there is an electric field magnitude at which the air becomes conductive, and the magnitude of that electric field is 3 into 10 to the power 6 volts per meters. So if there is a sphere of 1 centimeter radius, then we can find the maximum potential to which it can be raised to. We know that V, this is equal to ER. So if R is 1 centimeters, that means 0.01 meters. So the potential, this comes out to be equal to 3 into 10 to the power 4 volts or 30,000 volts. So no amount of charging could raise the potential of a 1 centimeter conducting sphere in air more than 30,000 volts. If you attempt to raise it even more, if you try to increase the potential by adding extra charge, that would just cause the surrounding air, that would rip off the electrons from the atoms in the surrounding air, and that would lead to the formation of this spark.